Stubble burning. What happens? After the kharif crop, mainly rice, is harvested in October-November, farmers burn leftover crop stubble to prepare fields quickly for the Rabi season, mainly wheat. This practice is particularly common in Punjab, Haryana, and parts of Uttar Pradesh. Why it's a problem? Stubble burning emits large quantities of PM 2.5, fine particulate matter, carbon monoxide, CO, and greenhouse gases like methane, CH4. These particles can travel hundreds of kilometers, severely affecting air quality in the Indo-Gangetic Plain, including Delhi NCR. Root cause: lack of affordable and sustainable alternatives to clear stubble, along with tight planting schedules, forces farmers to resort to burning. 2. Seasonal weather patterns. Temperature inversion. In winter, the ground cools faster than the air above, trapping pollutants close to the ground. This phenomenon, called temperature inversion, prevents pollutants from dispersing into the atmosphere. Low wind speeds. In winter, low wind speeds fail to carry away pollutants, causing them to accumulate in the atmosphere, leading to smog, a mix of smoke and fog. Dry season. The lack of rain in many parts of northern India during this time also means no natural washing away of airborne particles. 3. Vehicular emissions. Source of pollution. India has over 300 million vehicles, many of which run on fossil fuels. Older vehicles, especially those using diesel, emit high levels of pollutants such as nitrogen oxides, NOx, and PM 2.5. Challenges. Rapid urbanization has led to a surge in personal vehicles due to inadequate public transport. Traffic congestion worsens emissions as vehicles spend more time idling. Statistics. According to studies, vehicular emissions contribute around 40% to 50% of Delhi's air pollution during peak pollution months. 4. Industrial emissions. What happens? Factories, coal-fired power plants, and brick kilns release pollutants like sulfur dioxide, SO2, carbon monoxide, and PM10. Industries in urban peripheries often operate without sufficient pollution controls. Example: in cities like Delhi, neighboring regions like Ghaziabad and Faridabad have numerous industries with weak emission regulations. Contribution: industries account for approximately 20% to 30% of air pollution in India's urban areas. 5. Construction activities. What happens? Large-scale construction projects, such as roads, buildings, and metro systems, release dust and other particulate matter. Poor practices. Uncovered construction materials, debris, and open transportation of sand and cement exacerbate the problem. Contribution: dust from construction sites can account for up to 30% of PM 2.5 concentrations in some cities. 6. Waste burning. Types of waste. Municipal waste, industrial waste, agricultural residue, and plastic are often burned in open areas, releasing toxic pollutants like dioxins, furans, and heavy metals. Prevalence. Open burning is a common practice in both rural and urban areas due to poor waste management systems. Health impact. These pollutants are known to cause severe respiratory and cardiovascular diseases. 7. Use of solid fuels. What happens? In rural and semi-urban areas, many households rely on firewood, coal, and dung cakes for cooking and heating. Impact. The burning of these fuels produces black carbon, a major contributor to outdoor and indoor air pollution, particularly in colder months. Statistics. It is estimated that over 60% of Indian households still use solid fuels, which account for significant contributions to PM 2.5 and carbon monoxide emissions. 8. Firecrackers during festivals. What happens? During celebrations like Diwali, firecrackers are widely used, emitting toxic chemicals like sulfur dioxide, nitrogen dioxide, and heavy metals like lead. Impact. These pollutants combine with existing emissions, causing a sharp spike in air pollution. Studies have shown that during Diwali, PM 2.5 levels in cities like Delhi can increase by more than 500% overnight. 9. Urban heat island effect. What is it? Urban areas with less greenery and more heat-absorbing materials, concrete, and asphalt trap heat and worsen air quality. Impact: the heat intensifies chemical reactions in the atmosphere, leading to the formation of ground-level ozone, a harmful air pollutant. 10. Climate change effects. Delayed monsoons. Changes in monsoon patterns delay the natural cleansing of the air. Worsening wind patterns. Shifting wind patterns sometimes bring polluted air from one region to another, compounding the local pollution problem. Rising temperatures. Warmer temperatures in some regions contribute to ozone pollution, a major component of smog. Health impacts of air pollution. Respiratory problems. Asthma, chronic bronchitis, and lung infections. Cardiovascular issues. Increased risk of heart attacks and strokes. Premature deaths. Studies suggest air pollution causes over 1.6 million deaths in India annually. Economic cost. The World Bank estimates that air pollution costs India around 8% of its GDP due to healthcare expenses and productivity losses. Solutions and steps taken. Government initiatives. Graded Response Action Plan, GRAP 4 Delhi NCR to control air pollution during critical months. National Clean Air Program, NCAP aims to reduce PM 2.5 and PM 10 levels by 20% to 30% by 2024. Technology. Introduction of BS6 emission standards for vehicles. Promotion of electric vehicles, EVs, and subsidies for cleaner technology. Awareness campaigns. Encouraging waste segregation and banning single-use plastics. Promoting cleaner cooking fuels like LPG through schemes like Ujjwala Yojana.